All right, welcome to 11.3. Today's lesson, if we get through our solutions here, is a lesson that I've kind of been building you guys up to throughout the year by incorporating various problems in your homework. The textbook loves to hint at this concept in 11.3 that I'm going to teach you guys. So you're going to bear with me a little bit. Some of you guys will probably have already recognized it or have learned it based off of doing some of the challenge questions that I've placed in the homework. So if this looks familiar, it's because the book really likes to build this up here. Perimeter and area of similar figures. What we're going to do is we're going to calculate the perimeters of these rectangles. And this is just a basic example to help you guys hopefully see the relationship here. So let's see. Okay, so the perimeter, 12, 9, okay. Okay, so this perimeter here of the small one is 14. And the perimeter of the large one is 24 plus 18. And if we take a look at the ratios of these, okay, if I do the ratio of the small one to the big one, so 14 to 42, and I reduce that, that gives me 1 to 3. Now if you look at a relationship between their side lengths, 3 to 9, 1 to 3, 4 to 12, 1 to 3. So these rectangles are similar for starters. They have congruent angles, they're all 90 degrees. They have corresponding side lengths being proportional. And so if you notice here, the relationship between their side lengths is the same relationship as their perimeter. Their perimeters have a 1 to 3 ratio as well. And so that is true for any similar polygon. Okay. And then I suppose I should talk about the area too while I'm at it here. So the area of this one here is going to be 4 times 3 is 12. And then we'll go to the actual note page. Area equals, area of the small one is 12, and the area of the big one is 9 times 12, 108. Now if I compare the relationship of their areas, 12 to 108, the ratio is just a comparison of two things. Okay, that reduces to 1 to 9. Okay, so how does 1 to 3 and 1 to 9 relate? We might say it's triple, but really it's going to be squared. If I square this ratio, it gives me what I'm looking for. So the ratio of the areas of similar polygons is the ratio of their side lengths squared. So if I know the ratio of their side lengths, I square it, gives me the ratio of the areas, and that will allow me to find things without knowing all the information that I normally need to know to find areas. So this looks very complicated here. I'm going to show you guys an example question though on how to do this. Okay, so in the diagram it says the two triangles are similar, find the indicated ratio. So the ratio of their perimeter. So I don't even know all their side lengths, and that's what's cool about this. So the ratio of their side lengths is 8 to 12, okay? And it says red to blue, by the way, so we're going to go in that order. So the ratio of their perimeters is 2 to 3. So let's say that the red one had a perimeter of, I don't know, 30, okay? I could find the perimeter of the blue one without knowing any other side lengths, and so that's kind of neat. So the ratio is 2 to 3, and I know the perimeter of the red one is 30, so I can find the perimeter of the blue one by using a proportion. So if I cross multiply 30 times 3 is 90, and then 2 times the perimeter of the blue one, divide by 2, and the perimeter of the blue one would be 45. So that's what's unique about this. Now the ratio of the areas is 2 to 3, so what I'm going to do is I'm going to square that. So that'd be 4 to 9. Now again, let's say that the area of the red one was, I think I'm just making up some numbers here, 50. Let's just say it's 50. I can find the area of the blue one by using this proportion here. So 9. 4 over 9 equals 50 over the area of the blue one, and then you could cross multiply and solve for the area. So the unique or the interesting part about this is that you can find things without actually knowing all the measurements. Alright, so I'm going to just go over some sample questions here for you guys. You're installing the same carpet in the bedroom, in the den, the floors of the rooms are similar. The carpet for the bedroom costs $225. So this one here costs $225. Okay, carpet is sold by the square foot. How much does it cost to carpet the den? Okay, so what we have here is we're looking for the area, since we're talking about area, like the floor, the space. So the ratio is 10 to 14, so that would be 5 to 7. But that's not the ratio that I want because I'm talking about the area, so I need to square that. So 25 over 49, okay, so that's the ratio of the areas, and I know that this one here, the smaller one, the bedroom, costs $225. So then I can figure out how much it costs. Actually, I use a C for cost. The cost of the den there. So 225 times 49 is 11,025 equals 25. C divided by 25 divided by 25, and that leaves me with 441. There you go. You could have probably eliminated choices A and B as they're smaller, and the den is clearly bigger, so you had a 50-50 chance if you had to guess on that, I guess. But if we want the actual answer and it was a multiple choice, that's what you do. Okay, the perimeter of ABC, triangle ABC, is 16 and the area is 64. The perimeter of DEF is 12. Given that the fact that they're similar, find the ratio of the area of the two triangles, then find the actual area. So what I'm going to do is I'm going to draw some pictures here. We'll call this one A, B, C. There's just a ton of words here. There's a lot going on. And so what I'm going to do is just kind of go through this piece by piece and label the things that I know. So the perimeter of ABC is 16, so P equals 16 feet. And the area is 64, so I'm going to write that down. The perimeter of DEF is 12. And they are similar. Okay, so right now, all I've done is wrote down information. Find the ratio of the areas. Okay, so let's find the ratio of the areas. So in order to do that, I need to have the ratio of the side lengths. So 16 over 12 is the ratio of their side lengths or their perimeter. So the ratio of their side lengths or their perimeter is going to be 4 to 3. And then what I'm going to do is I'm going to take 4 over 3 and I'm going to square it, and that gives me 16 over 9. This is the ratio for area. Okay, so I have the first part done, then find the area. So the smaller one. Okay, so I'm going to use my proportion that I just discovered, or my ratio that I just discovered, 16 over 9 equals 64 over A. And you can cross multiply here, but I just noticed that this times 4. So I'm just going to do this times 4. 16 times 4 is 64. 9 times 4 is 36. There you go. So, fun problem there. Large rectangular baking pan is 15 by 10. Okay, so 15 by 10. And again, just draw pictures for these. It's going to help you a lot. Okay, and then the area of a smaller pan is 96. Oh, interesting. They give us the area of this one. 96 square inches. Find the width of the smaller pan. So we want W here. Okay, so we got to work backwards here. So first what we're going to do, since they give us the area of the smaller one, let's find the area of the larger one. 10 times 15 is 150 square inches. So if I compare the areas, 150 over 96, the first thing I'd want to do is reduce these fractions. So let's try 75 over, I'm just going to see if I can break these down a little bit. That divides by, so I divided by 2, and now I'm going to divide by 3. So I guess I could have divided by 6. Okay, now this is the ratio of the areas. So this is a new skill I'm going to teach you guys here. So what I'm going to do is I'm going to square root them, and that will give me the ratio of their sides because I'm going backwards. So the ratio of their sides or their perimeters is going to be a 5 to 4 ratio. Now, I'm looking for the width, so I'm going to use the 10 here. So 5 to 4 equals 10 to the width. I'm going to compare that to that, 10 to W. And so W equals 8. If I multiply by 2, multiply by 2, this little trick works for proportions. So that was a cool problem because we have to go backwards there. So that's a new skill for you guys. Okay, I'm going to pause the video here, I believe. Let's see what my time. Sorry about that. I think I paused the video. So I'm going to pause here. We're going to talk about this tomorrow and this tomorrow. And then I'm going to break this up on Schoology. We're going to do 2 days of 11.3. So kind of break it up, give you guys a little bit less of a workload for this section. Thank you guys for tuning in and see me for any questions. This stuff is interesting material here.